Advantages of sensors are that readings with sensors are a lot more accurate than those taken by human. They are not going to be, the readings are not affected by visual observation or like user error, or if somebody gets tired or bored, or like my sister says sometimes she's a nurse, and so a lot of times they have to take measurements or something on their patient or give them medicine at certain times or whatever, and all of that is based on like humans doing reading or observing even when they're using a sensor. And so a lot of times people will just like maybe not necessarily write down the exact value or the exact time that something happened just because they're rushed. So sensors are great for automating processes and eliminating errors like that. Sensors can also monitor information constantly. So sometimes you might want to put them on a timer where it only takes a reading every few seconds or every few minutes, but most of them have the capability to take readings multiple times a second. They will usually tell you the sampling frequency on the data sheet. It will be however many hertz, which is going to be however many times a second it can take readings, or that may be limited by your microcontroller. And sensors can respond to information immediately. So pretty much whatever frequency that your microcontroller is running through your loop, which may be like 500 hertz, so like 500 times a second, it would be 1/500th of a second between the time that the sensor found the information and the time that the alarm went off. So pretty much instantaneous. And sensors also can be used in situations where it is too dangerous for humans to work. So very high temperature, high radiation environments. Sensors are great for applications like that. Disadvantages are that sometimes the sensor can give incorrect results. So if it's not working properly, then the information that's going into the computer is not going to be accurate. So for this reason, it's good to have redundancy in controls. So you may want to use more than one sensor. That way, if one of them starts malfunctioning, the other one still works. So you take in the readings from all of your sensors, and then if there's an outlier, you can throw that out. But if they agree, then you know, okay, this is what's actually happening. So in conclusion, a sensor is a device that receives a stimulus and responds with an electrical signal. So it converts from one kind of energy domain, whether that's electrical, mechanical, thermo, magnetic, and converts it into an electrical output. The final stage is dependent upon the electrical properties of the materials. So this is basically whether its output is going to be analog or digital, depends on what type of materials it's made with and what the circuit inside of it looks like.